Believe it or not, what we're doing right here is just one extra thing. We're doing GEMS still, it just looks a little bit different. Previously we were working strictly with numerical expressions, and now just by looking right here you can see that we're dealing with algebraic expressions. Okay? Now it says evaluating an algebraic expression. Again, evaluate does not mean solve. Solve would be something if we have an equation. Evaluate means simplify it down. Okay? To do this, notice we have the two steps sitting right there. As usual, if there's steps involved, I'll put them up there right away. Replace, and replace means substitute. So basically, right now you hear me saying replace, but in about 30 seconds, you'll never hear me say replace again. I'm always going to use the word substitute, because substitute is the actual word we need to use in mathematics when we mean replace. So substitute the values of each variable into the expression. They're going to give you what each letter is worth. You plug them in correctly, and then you use order of operations to simplify it down. Evaluate using order of operations, just like I just said. Okay, so those are your two steps. Those are there to remind you how to do this if you forget. So we have this right here is our algebraic expression that they're giving us. You have to learn how to read these problems just as much as you have to learn how to do them. So it says evaluate that algebraic expression. And then it says if x equals 4, y equals 5, and z equals 3. So now they're telling me what all of those letters are worth. Perfect. I'll take all those values and plug them in, and then I'll just have exactly what I was dealing with last time. Okay? So I have 3, and now every time I substitute, I'm going to use parentheses. It's going to be probably kind of tedious. You guys know what tedious means? Kind of like stacking toothpicks on top of each other. That would be tedious. All right? So writing parentheses every time you substitute is going to be tedious, but it is important because once we get into negative numbers, if you're not using parentheses around those numbers as you substitute them in, it's very easy to screw up a sign. Okay? So we have 3 parentheses. X is what? 4. So I write parentheses 4 squared. Notice that it's still 3x squared, except now instead of writing 3x squared, I'm writing 4 squared. 3 times 4 squared. Continue on. Plus, I got parentheses, 2 parentheses 5. And now notice how I've written those parentheses. I made the actual grouping symbol here bigger, and the substitution parentheses a little bit smaller. And that's just for me to visualize that I'm putting those parentheses in there only because of substitution, not because I'm making new groups. Okay? So I have 2 times y, or 2 times 5, and then I continue, plus, all right, z to the third turns into 3 to the third. I'm going to put parentheses, 3 to the third, and then finish off the problem with that actual grouping symbol. Notice how I made that grouping symbol larger so that I can actually visually see it. Now, is this just like what we were just doing? Yeah, absolutely. Okay, so it's only one extra step, no big deal. And you'll find that in Algebra 1, that's pretty much what we do all the time. We just take what we learn, add one more step. And then the next day, maybe we add one more step to that. So we just need to evaluate this. Where do we start? It's GEMS, right? So grouping symbols first. Do we have any grouping symbols? Yeah. If you get lost on what you have, just look back at the original problem. The original problem had grouping symbols, so that means we do too, right here. Now inside the grouping symbols, we start over. Do we have any new grouping symbols here? Do we have any grouping symbols we have to take care of? No, actually. These parentheses here are just what I put in there because of the substitution. So those are not new grouping symbols. Where do we go now? The exponents. We have 3 to the third, which is 27. So I'm going to write 3 times 4 squared plus parentheses 2 times 5 plus 27. All right, we're still within the grouping symbols. What comes next? Any more exponents inside the grouping symbols? No. Okay, what's next? Multiplication and division at the same time from left to right within the grouping symbol, right? Just in here. So do we have any of that? Yes, and it becomes 10. 2 times 5 is 10. So now I have 3 parentheses 4 squared plus, inside the grouping symbol, 10 plus 27. And I know that some of you are probably capable of saying, I know what the next step is going to be. Still, for now, I'd like you to write down every single step. Okay? I want to see every step, because if you make a mistake and you're assuming things in between, I won't know for sure what you did. Okay, what's next? Still in the grouping symbol. The only thing left to do is add them, and we get 37. So now we have 3 parentheses 4 squared plus. Do I need to write the parentheses in there anymore? Nope. Once I take care of all the operations inside the grouping symbol disappears. So this is 37 now. Okay, what's next? So we start over, right? Any grouping symbols? Nope. Exponents? Yep. And it's 4 squared, which is, very good, 16. Now I'm out of room, so I'm writing it up here. We have 3 times 16. I can write that as that plus 37. Now what? 16 times 3 is 48. Good. 16 times 3 is one that comes up in this class all the time. It comes up on ACT tests all the time because it's not one that you typically think of when you learn multiplication tables. So you need to know that one. 16 times 3. 3 times 16 is 48. 48 plus 37, that's the only thing we have remaining. Anybody know that one without a calculator? 85. 85. If you can't do that in your head yet without a calculator, I understand. But really try to make yourself be able to do this math in your head, okay? Huh? Oh, excellent. Yes. We have an expression here to evaluate. It's important to see what the expression is. So make sure you see that this expression starts here and it goes all the way to here. I see a lot of people on this problem leave off that divided by C part just because they see the closing parentheses and they think it's over. So make sure you see that whole thing is actually the expression. And then they give us A equals 2, B equals 6, C equals 4. So now we're going to substitute in. And what am I going to write? Go ahead, Evelyn. And what should I write when I do that? Good. Put parentheses around the 2 squared. And then I got big parentheses because that is a grouping symbol. 3. Good. Okay, close that grouping symbol. Parentheses 4. All right. So I used parentheses around everything that I substituted in. Wonderful. Now what? We just did this, so everybody knows, right? Grouping symbol, and inside the grouping symbol, multiplication, 18. So we're going to write 2 squared parentheses 18 plus 5. We'll put parentheses around that 2 still. Divided by 4. Okay? Now what? Somebody else. Grouping symbol, addition, 23. Perfect. We have the 2 out front still, squared, parentheses, 23. I am keeping the grouping symbol this time, although it's not a grouping symbol anymore. What's that symbol telling me? Multiplication, yeah. Divided by 4. All right, now we're outside of the grouping symbol. What happens now? Exponents. 2 squared becomes 4. So we have 4 times 23 divided by 4. Now what? Multiplication and division from left to right at the same time. So what is 4 times 23? 92. Okay. So I'm out of room again. I'll come up here. We have 92 divided by 4. 92 divided by 4 is 23. Let me ask you something. Look at this. 4 times something divided by something, where do I wind up? In the same place. So right here with that 4 times 23 divided by 4, really the divided by 4 just undid the 4 times thing that I did in the first place, and I wound up with that middle number, 23. So if you kind of think about that a little bit, I would be okay with you jumping there straight to 23. This problem takes everything you've learned so far actually in this entire class and puts it together neatly into a problem. We have the volume of a sphere is 4/3 pi times the radius r squared. Find the volume if the radius is 3 feet. So actually what we need to do here is pull some valuable information out of here and write an expression for what's being said. And then it says find the volume if the radius is 3 feet. So that is what we're going to substitute into that expression once we find it, and then we'll evaluate it down and come up with an answer. So this just takes everything and puts it all together. It's like one more step. So let's take a look at the problem that we have and see if we can pull out some valuable information here. What is important? The pi symbol will be used for sure. More than that. That is like part 2. So for right now, we're just looking here. The find part is like after we find the actual expression. Okay. So just right here, what is important? The volume of the sphere. The 4/3 pi. Yeah, we're talking about a sphere. You guys know what a sphere is, right? Picture like a basketball or something. So it's good to have that picture in your mind. That's not information that I need to write my algebraic expression, though. The 4/3 pi is. What is 4/3 pi? How could I write that? Okay. 4/3 pi. What's the operation going on in between? Multiplication. Could I have written a word right here, 4/3 something pi? Times pi. Another word? 2 letters. Of. I could have written 4/3 of pi. And then that would make it probably a little bit more obvious, maybe. Okay, so we have 4/3 pi, then what? Times the radius r squared. So what's being done to r? We have r. What's being done to r? It's being squared. How do I write that? R to the second power. Now what am I doing to r to the second power? Multiplying it by the 4/3 pi that I already wrote down. So I could write a dot here, or I could write parentheses r squared, or I could write nothing at all and just put the r squared right there. 4/3 pi r squared is actually the formula for the volume of a sphere. We saw it in words, and now we just turned it into the actual formula for the sphere. Now that we have this expression, we can actually go on and find what they're actually telling us to find. Find the volume if the radius is 3 feet. So what should we do? Plug in 3 for r and then evaluate it. So I'm going to write what? 4/3 pi parentheses 3 squared. We're almost done. There's like 2 more steps and we're done. What happens now? Exponents. 9. So now we have 4/3 times pi times 9, technically 9 square feet. Now what? Multiply it all out. What is 4/3 times pi times 9? Okay, so 37.699. And I'm going to round that. It doesn't say to, but I'm going to round that to the nearest hundredth. which makes it 37.70. And then our units there would be feet to the third. Volume is always to the third on units. Now use the calculator on that, right? You don't have to. You can do multiplication in any order you want, right? And we have 9 times 4/3. That's like 9 over 1. I know we haven't really talked about this yet, but we can because you've learned it before. 9 over 1 times 4/3. How do I multiply fractions? Straight across. So 4 times 9 is hopefully still 36. And then 3 times 1 is, so divided by 3. And then I still have that pi that I don't know what to do with. I'm just going to leave it alone for now. Then we have 36 divided by 3. What is 36 divided by 3? 9. No, that's 27 divided by 3. 36 divided by 3 is 12. So we have 12 times pi. Our answer is 12 pi. Take your calculator and type in 12 times that little pi symbol and press enter. So the pi symbol is, come on. Where's the pi symbol?
Down by the H.
Down by the H. You got a little button right here that has a pi symbol on it and then a little arrow. So if you press that, you get a bunch of other symbols. Just click on the pi. It's easy for me to click because I'm using the pen, but you guys would have to just press enter. So you scroll over and press enter. Okay, what do we get for 12 times pi? Did we get the exact same answer? Yes, we did. Okay, so these are exactly the same. This one was done by just entering it in and having the calculator do all the work for us. Algebra 1, okay. This was done by simplifying it down and keeping the pi symbol. Algebra 2, yes, this is what we do in Algebra 2, all right? And I would be okay with you guys doing this in Algebra 1 as well. You will also do this in geometry next year. So just so you know, for now, this is okay, but later on, we're going to be here instead. Okay, moving on. From page 12 in your book, I specifically told you this is from page 12 in your book. This is one of the examples. We have an expression for spending money. You have left over after depositing 2/5 of your wages in savings. We need to write that expression. And then we want to evaluate the expression for weekly wages of $40, $50, $75, and $100. So there's quite a bit to this problem that we're going to talk about. So what this problem is trying to show you is you have some information here. You can organize that information into a table. And when you do that, then you can kind of see a pattern start to form. And once you have that pattern that's formed, you can write an algebraic expression to model the situation. So the expression comes right here. Here it is right here. From this. We have wages, 40. We're going to put 2/5 of our wages into savings. So if I get a paycheck, and it's a $100 paycheck, I want to put 2/5 of that into my savings account for later. Okay, how much is 2/5 of 100? Yeah, it's 20 bucks. So $20 would go into savings. So how much would I have left over to spend on my own? $80, all right? What did we do? We had our paycheck of $100. We figured out what 2/5 of that is. We multiplied it times the original. So 2/5 of $100 was $20. We subtract the 2 and we wind up with 80, and that's our total spending money, okay, in my example. So if you make 40 bucks, 40 bucks minus 2/5 of 40 bucks, 2/5 of 40 bucks is 16. Okay. 40 minus 16 is 24, so you'd have $24 left over to spend. You'd be able to buy like a tank of gas if you drive a moped. 50 bucks, all right, 2/5 of 50 bucks is $20. So we have 50 minus $20. Now I have $30 left over for spending money. And that's what this table is trying to show you, okay? So now what we want to do is come up with some other expression that we can write for any value of a paycheck. And that's what they did with this W up here. W, they use W. I just wrote N. So we take our original paycheck value and we subtract off whatever 2/5 of the original paycheck value is. So 2/5 times N. And like I said, they use W. It's already written right here. So the table, if you can put it into a table, the table starts to reveal the pattern. We have 40 minus 2/5 times 40, 50 minus 2/5 times 50, 75 minus 2/5 times 75, 100 minus 2/5 times 100. Notice what's changing every time? The 2/5 stays the same, but the 100 and the 100, or the 40 and the 40, each one of those are changing. And that's why that is our variable when we write that down. Okay, so now we have an actual problem for ourselves to try to solve. The shipping cost for an order at an online store, so maybe it's Amazon, I don't know, is 1/10 the cost of the items you order. What is an expression for the total cost of a given order? And then we need to find the total cost of the orders for $43 and so on. So let's try to set this up. If you're holding on to your calculator, you don't need to be holding on to it right now, so put it down. Thank you. We need to try to set this up. We're going to make a table and use the information up top to help us come up with the total cost for each order. So let's take a look at just $43. If I spend $43 on an online store, then I spent $43, right? Okay, so I have $43. Now, they're going to charge me 1/10 of the cost of the items that I order. Well, if I spent $43, then how much did the items I ordered cost? It's kind of like if your name is John, then what do people call you? $43, okay? The items that I bought cost me $43. That's why I'm being charged $43. 1/10 of the cost of the items that I bought is going to be my price for shipping. So how can I figure out my price for shipping? Multiply by 1/10, that's right. And then what am I going to do to that number that I get? Because I got to come up with a total, and total means, the word total means I'm going to do what? I'm going to add. So I have $43 and I'm going to add on the amount that it cost me to ship it, all right? And the shipping cost is 1/10 of the actual cost. So 1/10 of the actual cost is $43. Sorry, the actual cost is $43. And I need to find 1/10 of that, so I'm going to write 1/10 times 43. Actual cost, cost of shipping, total gives me the total purchase cost that it's going to cost me to buy this thing, or these things, or whatever it is, okay? So that's the point. Now we're just going to do that again for $79. My order now is $79, so I got to figure out what shipping is going to be, and then I got to add them together. So adding them together means plus what? 1/10 of 79. Got to do it again for 95. So we have 95 plus 95, and finally 103 plus 1/10 of 103. Now 1/10 is an easy fraction to work with. If you divide something by 10, or if you multiply by 1/10, what happens to the decimal? It moves over one place, okay? So 1/10 of $43 becomes $4.30. So if I have $43 and I add $4.30 to it, what do I get? I have $43 and I'm adding $4 to it. 43 plus 4 is 47, and then I also have 30 cents. So 47.30. Okay? 1/10 of $79 is $7.90. I'm going to add $7.90 to $79. You don't need a calculator for this. What do I get? $88.90. Good. Now 1/10 of $95, $9.50, and I'm going to add that to $95, and I get $104.50. Okay? And one more. 1/10 of $103. Good. $10.30. And I'm going to add that to $103, and I get what? $113.30. Okay? Do you see how to do that without a calculator? It is possible to do these fairly quickly without a calculator. If you're using a calculator, you're going to have to type in these numbers over and over and over again. But if you use your brain, you can logic your way into getting the answer actually easier than it is to type it out. So that's why I'm trying to get you to use your brain a little bit more. And that's it for the section.